Okay, next, so let's start from some big words in probability. So first of all, we are talking about additional law of probability. So when you are going to use add plus in probability. And then beforehand, we should know our keywords called mutually exclusive. So hopefully you know the word called exclusive. And so what does that mean? It means that you are talking about two events, remember, two events that cannot happen at the same time. So what does that mean? For example, like when you throw a dice, you have even number or odd number, so they are mutually exclusive. It can't happen at the same time, right? And then so like drawing a card, king and jack cannot happen at the same time, right? So as a result, when you are talking about mutually exclusive event, so then you just add up the total possible outcomes. For example, let's take going back to like the situation of king and jack. So for example, if E, you are talking about you want to get a king, F, you want to get a jack. Okay, you get a jack. In order to get P, E, or F, that means you want to get a card, which may be king or jack. Then you add them together. 4 king, 4 jack out of 52. You've got 4 over 13 finally. And this is a situation of mutually exclusive. You just add up the favorable outcomes together. But in some situations or many situations that E and F may not be mutually exclusive for two non-mutually exclusive events E and F, then besides you are adding up the situation, you need to minus their intersection. Wow, it's very terrible, right? Okay, let's take a look in the situation. For example, E is still talking about getting a king, but F this time we are talking about getting a spade. Do you remember what the symbol is it? Yes, that's spade. Okay, in this situation, you see that there is an intersection. So what do you mean by E and F? E and F this time you are talking about the intersection of king and spade. So there is one card in common, so which is called spade king. So in order to get P, E, or F this time, you want to get a king or spade, 4 king, 13 spade, but one of them, remember, one of them is duplicated. So that's why you need to minus 1, and then out of 52. And then finally is 16, right? 16 over 52, which gives you 4, 4, 4, 13, 4 over 13. So this is a situation of using addition in probability, mainly talking about exclusive events. Then we end up the idea in a question about, again, multiple scattering, right? So okay, let's do it together. And now you are going to consider 100 numbers, 1 to 100 inclusively, 100 numbers, which is in total. And you are finding part A, the multiple of 3 is selected. Okay, that's why it's 3, 6, 9 until 99, right? And then so these are the favorable outcomes. Again, you can find your own way to count it. Or if you remember, that's the way like it's 3 times 1, 3 times 2 for 6 until 3 times 33. So that's why there are 33 multiple of 3 over there. So that's why part A hopefully is easy. So the required probability will be total 33 numbers out of 100. 100 is the total, remember? And then so that's all. Part B, multiple of 5 is selected. It's 5, 10, 15, or until 100. Alright, can you find or use your own way to get how many multiple of 5 there? Yes, that's nice. Total 20, so which gives you 1 over 5. Okay, now part C and D, the words are very similar. So please note the keywords. One is called and, the other one is called or. So that's why you have to understand the keywords very carefully. Part C. Part C will be, okay, let's start from required probability first. 3 and 5 selected, multiple of 3 and 5. Can you understand this word is like multiple of 15? Because it's a multiple of 3 and 5 respectively, and each of them, they are prime numbers. And then in this case, so you have 15, 30. It's not very difficult to count it one by one, so let's all of them together. There are totally 6 numbers. So that's why it will be 6 over 100, which gives you 3 over 50. Okay, 3 over 50. Okay, that's about and. But when you're talking about or, the multiple of 3 or 5 is selected. So it's going back to one of the questions we did before in the previous video, part 1, in which when you talk about or, that means either one of them is okay. So that's why see whether you can use the idea of non-mutually exclusive situation. When part A, so there are multiple of 3 outcomes, multiple of 5 20 outcomes, and then in which these 6 of them they are duplicated. So that's why we minus 6 out of 100. And then so this is a situation of part D, and see whether you can understand it quite well. And by calculator, you get 47 over 100. That is, okay, E is talking about some logic words. It's not a multiple of 3, nor 5, not 3, not 5. Okay, you see that it's opposite to D. And then in this case, you can say as required probability will be 100 minus, so you remember it's 47 before, over 100 is 53 over 100. Or, so actually is what we are going to go through when we talk about complementary event, or is probability in total should be 1. So that's why when you talk about its opposite, then it should be 1 minus 47 over 100, which gives you 53 over 100 as the outcome. Okay, hopefully it's alright for you talking about addition or some situation of subtraction when we talk about probability. So finally in this video, we would like to go through a term called complementary events. So it's talking about 2 events together. So they put together, so it gives you a 1. So what I mean is, for example, when you're talking about maybe throw a dice again, the E, so for example, you're talking about even numbers 2, 4, 6. E dash, that means it's opposite, that means not. So what does that mean? That means it's not E. Not E, so what do you have is 1, 3, 5. So these 2 events together, so they make up all situations. So that's why the probability is a 1. Will be okay for you? The other situation is, for example, E is talking about like heart, when you're talking about playing cards, or heart cards. Okay, playing card. Okay, E dash, that means not heart. Can you count the numbers one by one? Heart card, they are totally 13, right? Not heart, there should be opposite, which means it's 39 cards. So you will see that totally there are 52 cards in total. So that's why PE plus PE dash, so it's all possibilities. That's 1. And this one will help us to do the calculation in the question as follow. Like in example 18 and 19. In example 18 is talking about a biased coin is biased coin, okay? So that means you can't use 1 over 2, 1 over 2. It's wrong, because the coin is biased. It's something made especially on it. And then it tells you, okay, if you get a head is 0.65, what if you want to get a tail? And you will see that head can be considered as one event. Not head, that means it's a tail, or not head. When you see that they are complementary events to each other, so that's why you can use 1 minus. So it's simply 1 minus 0.65, which gives you 0.35. That's all. That's the use of complementary events. Please note, you can use it very easily because it's asked quite often in your examination. Okay, another situation is when a dice is thrown twice and you want to see that the 2 numbers are different. Well, it's very hard because 2 numbers are different, maybe 1, 2, like 1, 2, 1, 3, 2, 4, and there are lots of possibilities, right? So if you expect that the number of favorable comes in, there are lots, then you think of 1 minus. What does that mean? That means now you can think of the required probability will be the opposite. Required probability will be equal to 1 minus the opposite when the numbers are the same, right? Because the numbers are either they're the same or they're different. So when you're talking about numbers are the same, then that's easier because you're only 1, 1, 2, 2, 3, 3, Okay, I don't write every one of them until 6, 6, right? So that's why it's 6 favorable outcomes in total. And now can you calculate how many total possible outcomes over there? Yes, you can use the rules of counting once again. So each dice gives you 6 results. Each die gives you a 6 result. Totally there are 36 results. And by calculator, you've got 5/6 finally. It's pretty easy, right? Alright, finally, so there's another situation. We have a load dice. Again, it's unfair dice. So there's something made to the dice to make the results different. You will see that getting 1 and 2 is 1/5, 1/9 respectively. While for 3, 4, 5, 6, actually we don't, so we can't assume that it's 1/6. It may be 1/7, 2/9, etc., etc. So that's why we need to be very alert about this kind of keywords. Unfair dice, load dice, bias dice, right, in the previous example. And then now you take a look. If the dice is thrown once, you want to get number less than 3. That means getting 1 and 2. So in this case, 1, 2, can you see that they are mutually exclusive event. So that's why you can just add up the probability together. Required probability. So equal to 1/5, 1/9. So it gives you 14/45. Okay, second situation, part B. Not less than 3. No, what do you mean by, well, repeat. What do we mean by not less than 3? Not less than 3, that means is 4, 5, 6, right? Do we include 3 as well? 3, is it less than 3? Not really, so that's why 3 should be included. So as a result, you will see that is the complementary event. Okay, complementary event to part A. So that's why we use 1 minus 14/45. So which gives you the outcome 31/45 very quickly. That's all for the mutually exclusive event as well as complementary events. So let's see whether you can get the idea quickly.